Hello everyone, friends and family. This is my Master Chief Halo Infinite helmet. Made myself over the last 6 months or so. The last thing I need to do is put lights into the side ports here. And in order to do that, I'm going to attempt to do the wiring for this helmet. And so put simply, the way it's supposed to work is I've got 4 of these LEDs and 4 of these resistors. I'm going to wire the LEDs in a parallel circuit hooked up to a 9-volt battery and its clip, just like that. And the idea is that whenever I press this really tiny switch, they should just come on and then come off super quick. So yeah, nothing else to it. So what I'm doing now is I'm going to solder the resistors onto the long end of the LED. This is supposed to be the anode, which is the positive terminal of this LED. And I will be connecting that with red wire to the 9-volt battery. Just like that. That's one down. Already got 2 of them wired up. Just like that. And then I'm going to put some heat shrink on these once they're all wired up. We're basically going to separate this into like halves. So half the circuit will be on red for all of the positives, and then the other half of the circuit will be on black, which will be the negative. So red being the positive is the power supply, and then the negative is being the return. So the next step would be on each of these resistors go in and solder the red to the end of the resistors and then heat shrink them. That way we've processed all of the positives on the LEDs. Red heat shrink. We're going to slide it down. All the way to just the red side. I don't want to get the other LED terminal, the cathode, because this has to get a black wire connected to it and then run off for all the negatives. So we're just going to gently put a lighter up to it. Kind of work it down as I heat it up. Be careful not to overheat it because I don't want to burn anything. Like I just did. that. So the resistor is actually inside that heat shrink tubing on this red wire. And everything's one complete assembly. So now he's going to do that for the rest of them. Want to say hi to the camera? You want to say hello to everybody at home? This is not food. It's definitely not food. Mocha Blondie. This is Mocha. Mocha's just a little lady. A little wiener. She's so precious. She's oh. Okay. Now, actually, see, I wanted to demonstrate, actually, I think I can. I want to demonstrate the flow of electricity to kind of make sure that everything's working properly. So the idea here is that because there is a resistor here, it will slow the flow of electrons in the circuit, reducing the amperage that flows through this LED. That's important because if it receives too much energy, it actually overheats the LED and will burn it out. It'll just straight up not work. So with this resistor attached, I should be able to connect the terminals of this battery and get light. Ta-da! So it's working. Be to process all of the negatives on these LEDs, negatives being on the black ones. So what we're going to do is just same old thing. We're going to strip these. And then solder them to the negative terminal of these LEDs. Kind of the same. Okay. So just like that, I've got all of these LEDs processed. Each one's got their positive and negative wired up completely. For this helmet specifically, we're gonna have to do two pairs essentially. So 2 on one side, 2 on the other. What I'm thinking is kind of going off loosely based off of my diagram here. I will have 2 branches of both positive and negative going to one side and then one to the other, but they will all be connected here centrally. So what I'm going to do is I'm going to even these all out first of all. I gotta keep it clean and tidy. And then once I do that, I will wire all of these together basically. So 4 and 4, they're split equally in half. Those halves will then attach to the switch. This little tiny guy, this little switch. You might be able to hear it clicking. And then this switch will be basically positive and negative, feeding into the power supply. And it will all run through this little switch. That's the plan. Make sure nobody's loose. I don't need to like pull with all my strength, just a little bit. Make sure it's connected. Yeah, I'm happy with that. Okay. So now what I'm going to do is I'm going to power or solder from this 9-volt battery adapter, the black and red, to the switch, and then from the switch to my main circuit here. From what I can gather, here, let's see if I can give you a better view. From what I can gather, this switch is a momentary switch. It has 3 pins. One's your input, your output, and your ground, or your neutral. There's not going to be any grounding to the circuit. It's isolated in this helmet, and the voltages are so low that I'm not in any serious danger of electrocution, so it's not necessary. But if I'm not mistaken, the red lead needs to go on this small one in the center, and then the negative needs to come off of either side. The idea being that when these switches clicked, it will complete the circuit. Okay, so with that being done, that is the switch included into the circuit. Mistakes were made. Wasn't able to heat shrink that other side, but that's okay. So what I'm going to do now is connect this to basically the positive and negatives of this circuit. Okay, now we get to do the ultimate test, which is to plug in the battery. Connect this 9-volt battery, and when I push the switch, ta-da! All 4 lights come on for the flashlight. Okay, so I finished dressing up this little wiring thing I've got going on here, just to make sure when I push the button, all the lights turn on. That's perfect, that's what we want to see. So now we're going to take the helmet, we're going to kind of eyeball where it is we want to mount everything. I'm thinking around this inner lower lip. So the next step would be to create the holes in these little light ports. And I think the way I'm going to go about that is actually, I'm going to gauge the diameter of the LED bulb. So it's like a friction fit. You're not the fanciest, they are plastic clawed calipers, but they're the ones I've got. So I can see right there that is about 5 millimeters in diameter for this LED. So what I'm going to do here is just find a corresponding bit that's kind of the same size. 4.7. So the LED is 4.8, this is 4.7. I bet if I wiggle this drill bit around while I'm drilling, I can kind of get it close to that 4.8. That's about as close as I'm gonna get. And that is 3/16 of an inch. But if you've ever drilled into anything like plastic, wood, metal, you usually want to work your way up to your final size instead of just full sending it. So I'm gonna go with maybe something right in the middle. Yeah, we'll go with this. So I'm going to start the hole with a 7/64 bit. Try to get as center as I can inside these flashlight holes, and then I'll go back in with the big one and kind of get it down to final size. I just need to put the light covers on. Okay, so a little update. So far, I've got the wiring harness glued in there. There's the 9-volt battery, there's all the wiring. The holes were drilled into the side lights. The LEDs fit in there perfectly, which I'm super happy about. And then if I push the switch, ta-da, flashlights, side lights come on, they're perfect. The only thing I'm gonna do now is I'm gonna take these little, I guess, detail covers for the lights. I'm gonna put the tiniest bit of hot glue and then push them into place, and they should be like 100% done. And there we go. That's the 100% game accurate, finally finished. Let's try to get my finger on there with lights.